right, folks, it's Bass Action back in action here. In this video, we're now going to take what we just learned about polar coordinates and we're going to learn how to convert those back to what they would look like in their rectangular form. And being comfortable with how to plot them is going to be an important skill. So up here at the top, I've got some basic things that we already know from our trigonometry, okay, that cosine of theta is x over r. Now, of course, we've mostly been working with this in a unit circle where the r value was just 1, so we got to ignore that most of the time. But remember back to the very initial beginning of the unit circle, we did define it as cosine theta is x divided by r. Now, that being said, we can cross multiply this little equation here. We're just kind of mentally cross multiplying this. And what that tells us is that in x value, think rectangular form, x is equal to r cosine theta. And if we do the same thing with our sine formula from way back at the beginning of the semester, we would end up then with y equals r sine theta. These two formulas then are going to allow us to move back and forth between our rectangular and polar forms. So when you look at these examples that I've got here, you'll notice I already have some things pre-filled out, so you might want to pause and write those down. But I wanted to be able to fill out the most important stuff with you. If we are told that we are going from polar to rectangular form, it's important for you to recognize the order that you're going because that's going to tell you that the ordered pair that you're given is in the form of r comma theta. Okay, so all the points here are in that form r comma theta. Using the formulas that we have up above, I can find the x-coordinate in rectangular form by taking the r value and taking the theta value and substituting it in to the appropriate formulas. So the new x value will be 4 times the cosine of negative 2 pi over 3, and then 4 times the sine of a negative 2 pi over 3. So from our unit circle days, we can easily calculate that as 4 times a negative 1/2, and then also 4 times a negative radical 3 over 2. And of course, if we just clean those up, we're going to get a nice negative 2 and then negative 2 radical 3. Now, this is where having an understanding of how to plot polar points is helpful, because if I plotted that point in its rectangular form, it would be in the 4th quadrant. And then if I'm comfortable with how to graph the point 4, negative 2, 3, I would find that it also would end up in that 3rd quadrant there. I think I said 4th just a second ago, but I meant to say 3rd quadrant there. Now, if we continue that process and continue just doing that basic arithmetic, we can find and convert all of these. So we'll have a negative 5 on our next one, and cosine of 11 pi over 6 is a radical 3 over 2. Following your signs and being careful with your signs is really important here. And a negative 5, and this one's going to be times a negative 1/2. So when I clean that up, I'm going to get a negative 5 radical 3 over 2, comma, a positive 5/2. So that's going to be its form in rectangular form. And of course, if I plotted that, it'd be in the 2nd quadrant. And if I plotted this original polar point, it would also land in the 2nd quadrant. So it's just an important skill to be able to do a quick visualization of where they would be. So going on to my next one, now we've got a quadrant angle, and those sometimes stump students a little bit. So I'm going to have my negative 3, and cosine of 3 pi over 2 is 0. And then on the y, I'll have a negative 3, and sine of a 3 pi over 2 is negative 1. So we want to be careful with that. So that point in polar form is going to be 0 and a positive 3. Knowing these quadrant points is going to become really important for us later. So when I plot that point, it would land up here, and I, of course, could verify that from its polar form. Now, my last one here, what I want you to notice is that this time I didn't give you an angle that was from my unit circle. So in this case, I would need to take out a calculator, a good scientific calculator, and you would need to know what the theta value is in. So unless it has been labeled with the degrees, you should know that the theta would be in radians. If it was degrees, I would have a degree symbol on it. So if you convert your calculator to its degree mode, get that in the proper mode, and type this in your calculator, you will get for the x value a negative 1.60. And for the y value, you're going to get a positive 1.20. We're just rounding those. So our rectangular form would look like this. And if we plotted that point in the coordinate plane, we would end up in that second quadrant. And sure enough, if we plotted this point right here in polar form, it would also end up in the second quadrant. So that's just an important thing to keep track of. Now, these last two examples on this page, converting equations back and forth between the two forms, I'm going to tell you, you're not going to need to know a ton about, because we're going to do a lot of polar graphs later and you'll start to recognize these. But for right now, I just want you to have some comfort with how we are getting between the two forms. So we're going to start with understanding the rectangular equation for a circle is, of course, x squared plus y squared equals r squared. Again, that goes all the way back to, we talked about it on the original unit circle. So option 1, and you just kind of have to play with them sometimes if you're not sure, what we're trying to create are these terms, okay, these values, so that we can do some nice substitutions. So on this first one, option 1 would be to square both sides. So if I square both sides of this equation, I get r squared equals 100. And then r squared from the equation I can see right there would substitute and become x squared plus y squared equals 100. So here's what I want you to know, what your big takeaway is that this equation, x squared plus y squared, is a circle. And what I want you then to also know is that this equation here is a form of a circle in polar form, okay? So both of these equations represent the exact same circle. So this is really just dipping our toe in the idea of starting to see this is an equation for a circle, and this is what we are now also going to come to know is an equation for a circle. The next one, squaring both sides, wouldn't be as convenient for us, and if you're not sure why, just try it and you'll see that it turns out kind of messy. So we're going to have another strategy, and it's going to be to multiply both sides by r. And if I do that, I'm going to get an r squared, and then I'm going to get a 10 r cosine theta. Now, I could write this in any order, but experience tells me that it makes most sense to write it like this. Just a little bit more experience that I have. From the last problem, we know that r squared could become an x squared plus a y squared. And then from up above, we know r cosine theta is the same as x. So now we can see that, again, we do have an equation for a circle, but this one's center is not going to be 0, 0. So what we're going to do on this is we're going to go real quick back to our completing the square days. We're going to move that 10x to the other side. We're going to think about how to complete the square on that. And then, of course, we would have a 0 plus whatever it takes to balance. Good, completing the square days tells us that's going to be 25 and a 25. So this equation is going to become x minus 5 squared plus y squared equals 25. So again, what I'm wanting you to start just to get comfortable with is recognizing that this right here is actually a type of circle in polar form, because we know that when we convert it, it's turned into an equation that's also a circle that we should be familiar with from our geometry days and from the beginning of the school year. Okay, so we're going to do a lot more with polar graphs, but right now I just want you to start to see a few little things on what they look like in polar form and what they look like in rectangular.